So here I send you this. You have to study each of individual, how to come out with sum, how to come out with the average, how to find the maximum, how to find the minimum, how to print the whole array, how to search in the array, right? Last week we go through this. Okay, you have to remember that. And then here is a pattern how to come out with maximum. Set the initial maximum value with the minimum value, and then you have continue condition, initial condition, continuing condition, update condition. And every time you found a value, if it is greater than current maximum value, set the current maximum value to the new value, something like that. Okay? You need to conceptually able to describe what it is. Set the initial maximum value to the minimum. So whenever there's a new value, you will be able to replace it. Then we traverse through the whole array, and then if a certain element is greater than current maximum value, setting the current maximum value with the current value. So it's just like whenever I go through the array, I pick it one by one, I get a value compared to current maximum value. If it's greater, then I actually set that to my maximum value. And next time I move on to continue to compare, until it actually finish the whole array. And then at that time, I return my maximum value. Is that okay? Mm-hmm. And in AP course, I will give you more of this different kind of pattern. Not only current pattern I show you, but in this introduction to Java level, you've got to remember all of these, not by copying every character, but by remember how you come up with this pattern and being able to explain to yourself and explain to me. Last week, I also teach you this one way to create an array like this. Second way is to create this and then update later using the for loop to update the content of the array. Third one, you initially with null value of this one, and later you need to create a new array by adding this new double bracket thing. Remember that last week?
Yeah.
So these are something you need to be able not only explain to me, but also be able to write right away, okay? Mm-hmm. Okay, so that's enough for us to explain how to come up with an array and how to help you to be able to learn math and computer science. And we later, when we go to AP computer science, we will repeat that. But now let's do random number and histogram and enhanced loop, okay? And then counting characters is different idea. So let me start, since we are talking about loop, I will jump over, I will not do this random number first. I will do this enhanced loop first, okay? I'll do the enhanced loop first. Okay, what is enhanced loop? Okay, now I have an integer array. Bracket means an array, right? ARY equals something like this, and I have whatever number I want to have. Okay, that's the number I have, right? And then I'm trying to create a sum, so integer sum equals 0, and then for integer I equals 0, I less than ARY balance, I increase, and each time I should have sum increased by ARY of I, right? I'm sorry. And then here is ARY, okay? And that is the sum. And then I print out my sum. So conceptually it's something like this. Each time I get the data from here, and that data will be sum with my current accumulator. My accumulator called sum. So this is A plus sum. A and sum plus together, you'll go back to update sum. Okay, let me draw a bigger chart. This one probably not good. Okay, I have a array. Each time I get a value, this one called A of I, and this A of I sum with my sum, and then the result update my sum. Right? It's something like this. Each time I get a value from my array, and then this thing's called A of I, the sum with the current sum, and then the result go back to update my sum. It will be something like this. Okay, and then I could move in for the next value from there, right? That is the trying to calculate the sum for a certain array. Now today we introduce the idea of enhanced loop. And for enhanced loop, it is not like for initial condition and then the continue condition, and then the last one is update statement, right? That's the old for loop. That's the current for loop we teach. The enhanced loop is not like this. Enhanced loop will be, it's also called, this enhanced loop is also called, the name is also called for each loop. So the grammar for each loop is for each integer I from the array ARY, and then here I set integer total equals 0, and then right here I have my total plus equals I. So for each integer, I increase my total with that integer. This is called for each loop. Is that okay? So we actually compile and run. Let's call for each loop. Two are identical. So the previous one is for initial condition, continue condition, and update condition. So each time I use my index I to get a value, right? That's for each index. For each index, and the index less than the array length, I increase my index. That is for loop. For each loop is that for each value I in the array, integer array. So this I is different from the other I. So this I is index. Index means when you have an array that's 0, 1, 2, 3. This is called index. So for each index I, index less than the array length, index increase. Okay, that's a for loop. This one is for each value I. Value I means the value stored here. And then that value add to the total. Is that okay? So for loop is for each index. For each loop is for each value in the array. Okay, let me repeat one more time by a different example. So here, let's do this. Let's do double array A equals 5.5, 3.2, 1.9, 4.7, something like that. Okay, that's a double value. So then I have the double sum 1 equals 0.04 integer I equals 0, right? And then here I less than a that length, right? I increase. So something like this, I try to create my sum 1,000 times, right? Then I will remember the how to program, how to do programming real quick, and I will remember this pattern. It's just like a formula in math, right? So this one give me my double arrays value, sum value. Okay. Okay, and then now I want to do for each loop. Right. Now I want to do for each loop for this double. So I do for each double value D in the array A, and in the array actually I use a column. So for each double value D in the array A, what I do is actually my, sorry, I erase one copy paste. Okay, and before that I also need to declare a double total 1 equals 0.0, something like that. And I can do total increased by my value, double value. It's not double index, it's double value. I'm sorry, it's not A, it should be total. 1. I'm sorry, it should be total 1. Okay, then I compile. And then I run this loop. Okay, also been 15.3. So usually the variable I use here, if it's double, I will use D. If it is a, say, let me actually show you another one. Say I have a string, and then SS equals, let's call this a string array, right? And then here I have string welcome to Java, and then exclamation mark, okay? And then I will try to connect them all together. So I have for each string S, in SS, and in should be colon SS. And I will do, oh, okay, I'll connect them together, append them together. So I should start with my str equal empty string. And each time I have my str append with my S, but my S actually is a word, but I want to insert a space in between each of the word. So now let me actually print out my str, and then I run. Is that okay?
Yeah.
So this also is a sum loop, except that the sum is not taking sum for the whatever. It's not really taking sum for a certain value, but it actually connecting all the a substring together into a bigger string. Is that okay?
Mm-hmm.
And that is another enhanced loop. So now, are you okay with the enhanced loop? For loop is for each index, an index coming from the initial condition to the with the continued condition, and then every time we increase or update the index, right? And then for each loop is for each value, and the value can be an integer, can be a double, can be a string. So sometimes I would say for each index, for each integer value I in the array, or for each double value D in the array, or for each string value S in the SS array. Is that okay?
Mm-hmm.
That is actually the enhanced loop. Okay, and let me do this right here. I also still add a system that out that line is the slash f. Okay, so now whatever. Okay, that's the enhanced loop. That is the enhanced loop. Let me run one more time. Make sure it works. Okay. Now let's turn to the next idea. Random, about random numbers. Okay, what is random number? Sometimes we play game, right? So if your game every time come out with the same scene, same scenario, it will be boring. So sometimes we will need to have this random number. Okay, so I remember that last time I teach you some program called dice, right? Maybe I teach you already. Okay, I maybe teach you already about dice. Now let me do it again. Okay, let me do it again. So let's do this dice program, public static void name. I'll try to mimic the concept of storing the die. Okay. So here, if I have a function called public static, and then I have integer toast die. Okay, and this one it should return me some integer value result, because initially I set it to be 0, but I want it to be the result that I obtain from my toasted die. So first, the random number generator is called mass.random. Okay. First, you need to know about the mass.random function. The mass.random function will return a double value, not a integer. So let me try to multiply that is for the time being, and then I actually print out this. And then here I say result. I try to print out the results. Okay, that's good enough. And then right here in the main program, I say integer I equals 0, I less than 100, I increase. So this will totally use the toast by 100 times. So I print out print line, and I say experiment and plus I plus equals, and I do this. Plus toast die parentheses. So each time I run a toast die once, and then got a return value, and then I print out the return value with this format. So let me compile, and let me run. Okay, so as you can see, the mass.random run for 100 times from index 0 to index 99. right? Each time you get a certain what? Every time you get a value in between 0 and 1, in between 0 and 1, but not including 1. Okay. I probably have teach you this already, but here I repeat again. Okay, so I started from here, experiment below. So here, and let me do this. Let me again clean out the whole thing. Okay, compile, and then right here, let me actually run. Okay, so all the value actually is randomized, and then the value actually, if I run the second time, my 99 is 0.23, right? And then if I run again, the value change. I run again, the value change. So it's really a random number. Is that okay? It doesn't repeat itself. Every time you run it, it ends up with different value. Okay, for each experiment. So that's truly a random number. And what happened is this mass.random is a function that gives you a value of from 0 to 1, but not including 1. This is the range. Is that okay?
Yeah.
That is a random number from 0 to 1, but not including 1. So now if I want to generate a value from 0 to 5, but not including 5, what should I do?
Multiply by 5.
Okay, good. So and then multiply by 5. So if I say I multiply by 6, right? So the value would be 0 to 6, but not including 6, right?
Yeah.
Is that okay?
Yeah.
Okay, so now let me run it. Okay, I'm square. I run it wrong way. Okay. Okay, now it has some 5 point something, right? But there is no 6. It's from 0 to that. Okay. Now I'm creating a die, right? So die have how many face?
6.
6 face. And then if I say, okay, let me quantize it, convert it to integer, and then actually here the result I say is integer, right? So by having this casting, I change the value from this master random from actually this one will be from 0 but not including 6. This one will actually quantize. The quantization will be if you have 0.55, it will become 0. You have 0.99, it will also be 0. If you have 1.01, that will become 1. It is a truncation, truncate all the fractional part. So that would be a function. That would be a function from 0 to 1. It will all be the y all be this from 1 to 2, but not including 2. The y value will be 1. From 2 to 3, not 2 to 3, the value will be 2. Is that okay?
Mm-hmm.
What's the name of this function?
I forgot.
It's called floor function. And if I have a function, actually it's actually from 0 to 1, it all jump to 1. It should be something like this. I'm sorry, not including 0, but including 1. This one is called ceiling function. Ceiling, right? Your house, you have a ceiling, you have a floor, right?
Mm-hmm.
That one is called ceiling function.
Uh-huh.
And then floor function is also called as greatest integer function. The ceiling function is also called as least integer function. So let me bring out these different things from internet. You got to remember this. That's why I'm teaching another course called Doing Math for with Python, because that you need that. So greatest integer function. Okay, greatest integer function is like this. It actually is a floor function. So you have 0.5. It actually will get the y value of 0. That's called greatest integer function. But it actually is a floor function, and the notation is like this, using the bracket and put an x over there. That's called ceiling function. Okay, and then there is another one called least integer function that is actually called the ceiling function. And ceiling function is like this, not including 0, from 0.0001 to 1. That's actually called ceiling function. So ceiling function's notation is like this, right? Floor function is like this. I'm sorry, lower part. Okay, it's a floor function. This one is called ceiling function. And sometimes this ceiling function can use the typewriter. You can use a bracket, but outside bracket like this. And then sometimes the ceiling function you use something like this. Okay, because of a typewriter. But actually the mark is like this for ceiling function. This for the floor function. Is that okay?
Yeah.
They are two different two way to actually move your integer to the closer. I'm sorry, move your double value to closer integer value. There is a third function called rounding function. Okay, so so actually, if you have a point something something something, get rid of it. That one is called floor, right? And then add one to a plus 1, that's called ceiling. And there's another one, actually is a plus 0.5, take the ceiling. That one is called rounding function, right? So if you have a that is actually 4.5 plus 0.5, and you take the floor function, you should get 5.0, right? That's your rounding function. And then if you are 4.49 plus 0.5, you got 4.95. Sorry, you go back to 4. That actually is a rounding function, 4.49 round to 4. 4.5 round to 5. Is that okay? So the rounding function is actually what? The rounding function is actually the x plus 0.5 taking floor function, and that's y function. So here you have this one is a ceiling functions chart, let me go back to the flow functions chart. Flow functions chart is right here. Flow functions chart right here. And then what is the relationship between the flow function and rounding function? So rounding function is flow function with what transformation? With what transformation? Shift left by 0.5. Okay?
Okay.
So it will be shift left by 0.5. It will be like this. Is that okay?
Yeah.
Shift left by 0.5. Okay? Three integer function. Least integer function that's taking ceiling. Greatest that's taking floor, right? Another rounding function that's taking floor by x plus 0.5. Okay? Now, go back to our diagnose. So this one, I taking the floor function using the cast function. Cast function is taking floor. So what will be the result if I convert a value starting from 0 to 6, but not including 6? Well, it will be. I take a integer, so that will become 0, 1, 2, 3, 4, 5. So my range will be something like this, right? But is that the real die value that I want?
No.
So what should I do?
Go to 7.
Go to 7. So what should I do? What should I multiply my formula here?
You multiply it by 7 instead of 6.
No. Multiply by 7, you will get.
Oh, you multiply by 6 plus 1.
Yeah, so you should plus 1. And then, so actually what you need to do is right here, you need to do plus 1. So this formula I told you, it's called this. Remember this, okay?
Okay.
Mass random times count. Count is the number of the samples plus base. So this will give you the number starting from base, then base plus 1, up to what? Up to base plus count minus 1. Okay, so it actually is a base plus I come from 0 to n minus 1. Is that okay? And that's totally n different numbers. Is that okay?
Yeah.
So now let's look at this experiment. Okay, I have this. Okay, and then I do experiment. Let's run for 100 times. It's 01. What happened to it? Oh, I have this. And actually, this is always it being truncated before I time 6. So this is wrong. I should put a parenthesis over here to make sure you do the multiplication first before it being quantized. Okay? So now let's like this. Is that okay? It's 1 to 6 now. This is 1 to 6 now. So remember the equation I told you. Remember the equation I told you is what? The equation I told you is mass random. You probably need to copy down in your notebook, okay?
Okay.
Mass random times count, number of elements, parentheses, integer quantized, and then plus base. Or baseline. Sometimes I call it baseline. So baseline is the lowest number. Base is the lowest number. So it's a base plus 0, base plus 1, up to base plus n minus 1. Okay? You generate such random samples. Let me know when you are done. Okay.
Okay, I finished.
Okay. You finish our clean up. Okay. Now over here, I will say final integer, and then I say count equals 6. Final integer, and then I say baseline equals 1, starting from 1, right? So right here, do you still remember the constants? Constant is something that you cannot change, right? And here I miss the static. Static function can only get static data. Okay, and I'll teach you that data. But now, for time being, let's do this. That's a die, always generating the value from 1 to 6. Okay, but now if I want to have from 1 and then 3, 5, 7, but still 6 number, what should I do?
You do the percent percent 2 cannot equal.
No, I do this. After I get the integer sample, right? After I get the integer sample, I time another number of steps. Okay, I time another sample called steps. Then each time, originally I create a value from 0 to 5, right? And then a time step, it will be 0 to 4 to 10, right? And then I plus 1, it becomes 1, 3, 5, up to 11. Okay? So that's the way I use this formula. It's actually mass random times count, take quantize, and then times step plus baseline. Okay, now I have the 2 as my step. So I will create 1, 3, 5, 7, 9, 11. That's the sequence I created. Right? So it's only the odd number from 1 to 11. Where do you get these things? Actually, this one is a random arithmetic sequence. You got it?
Yeah.
Which one is D?
2.
The step is D, right? So here, this one is actually D, right? Which one is the A not A1?
1.
A1 is baseline, right? And which one is N?
6.
6 is actually N, right? So that's the random sequence we can generate. Now I have a question now, okay? Since this is a random sequence. Now, can you generate a random sequence from -3 and 0 and 3 up to 15?
Oh, okay. So instead of can you change step to?
Yeah, tell me which one I should change to what.
Okay, change step to 3.
Okay, step to 3. Let me change step to 3, and then
and then change baseline to -3.
Yes. How many
And
count?
change to 7.
Are you sure?
I think so.
Did I tell you that to calculate this number?
Oh wait, 8.
3 as a box, right?
Yeah.
3 as a box. So 3 as a box. The next one that's not included is -6. So you should have this one plus this one divided by 3. That's what?
7.
7. Okay. Always remember the formula I teach you, okay?
Okay.
That's a box. So here you have a 7. Let's see if that is true, okay? Since it will have equal chance, we generate for 100 times. Each one should show up at least once. -3 up to 15, right? Is that good?
Yeah.
Okay, so that's the random sequence. I teach you the using the random number to generate a random sequence, right? I teach you that, and then I do the experiment. That's for time. But let's go back to actually having this count as a 3, slab as 1, and the baseline as 1. That's the normal die, okay? That's a normal die since we know it already. That's a normal die. We need to do something else. Okay, that's a normal die. So here I finished teaching you about generation of a random number. Okay, and you can read this material. Now I need to build a histogram. What is a histogram? Histogram is the tally result for the number of the occurrence of for each one. So here I would have my histogram would be an array, say static integer histogram. It's called histogram, and then equals new, and then integer of 6 element. Okay, and then let's do 7. Let's do 7. Okay, I have a reason. Okay, I have a reason to use 7 instead of 6. Now let me here put like count plus 1. Okay, let me do here for counter 1. This will call histogram. Okay, now what I will do is here, instead of just printing out the result, I'll say actually my histogram of, let me do this integer x equals toast die. So my toast die result, I print it, right? Because I want to reuse it, so I need to store it. And then my histogram of x will increase, right? And then here I'll say for integer I less than count, I increase, right? Here I should have I equals 0. Then I'll say system.out.print9 die of I occurs plus histogram of I times. Okay, then I compile and then I run. Okay, it said that 0 occurs 0 times. So here I should do I count from 1 to count plus 1. So I sacrifice the 0 location. I don't use that. Okay, I don't use that. But then I can easily create my die of 1 occur by 16 times, 2 by 14 times. So from I done the experiment for 100 times, it's not a fair. It's not a fair die. It's not even. So now let me actually here I don't use 100. Here I do like called iterations. Okay, and then I go back to here. Right here. Okay, I have a number of experiments for 100,000. Okay, keep doing, keep doing, keep doing, keep going, keep going. I'm happy. Is that close to each other now? Much better, right?
Mm-hmm.
So as the number of experiments increase, my die seems to be more fair, right? So if I do just 100 times, it actually is a little bit not that fair actually. So more experiment, you're approaching to everybody approaching to the average value. That's the observation. As I adding more zero to the number of experiment, it's become closer, closer. Whenever I add one more zero in there. Right? Mm-hmm. It gets closer and closer. And if I add one more, that's even closer. So that's this one, the collection of the occurrence number is called the histogram, the frequency number for each die value that under a certain experiment. So here the iteration tell you how many experiments I would perform, right? And then each one I have a random sample coming from baseline 1 to 6. And then each time my step size is 1. Is that okay?
Mm-hmm.
And my histogram I use the count plus 1. And then I sacrifice 0. So right here, if I don't use like count plus 1, I say, oh, I don't want to sacrifice for that. I actually do this, starting from 0 to here, right? So here I would need to do right here, I should say I plus 1. And histogram of what? Of I? Is that okay?
Yeah.
So right here, I have a die toast. I have die toast. Right here, I should have a x minus 1. Because x is from 1 to 6. X minus 1 is from 0 to 5. So my histogram actually, if I got a die toast of 1, I put it at histogram 0. I have a die toast of 2, I put a histogram of 1. And that's why I told you, if I sacrifice a histogram location, the program will be easier to understand. but
okay.
If I don't, I have to be carefully adjusting the index. Is that okay? Mm-hmm. But since I want to give you the example, I make this complicated version for you, so later you study it like that. But if you don't like it, just +1 here and use the normal histogram location. And here actually starting from 1 to less than equal count. Okay? So now, right here, I teach you how to build a histogram. You can read through here. Okay? I cover the enhanced loop. Okay? And here is the counting for character. Okay? The counting for character. And then here is the double room. It's double room. Okay, now we actually okay. I did in different fashion than this textbook is doing. Okay, so you should also come here to study it because I don't want to repeat it and I won't actually give you the die example. Okay, but I cover the concept for this random number and then histogram and then here for each loop. Now let's look at counting characters. Okay, so a word is said to be a double word if every letter appear in the word exactly twice. Okay, if the letter is exactly twice, write a method called is double word to take the string to check whether it's a double word or not. Okay, so apparently this is a histogram problem, right? Because you are given a string and then I traverse through the whole string. And then if my character, my histogram for each letter occurs, and then it actually is occur by 2 twice, say like mama, then my M happened 2 times, my A happened 2 times, so that would be a double, right?
Yeah.
Is that okay? So actually here, if I is a llama, llama is not, okay? Mama is, llama is not. And then here is a double colon, so I set my histogram to 26 entries, right? And the string I receive as a S actually will be converted to the lowercase. So the mama, capital M, it will be converted to lowercase. And then I use the for each loop. For each character from my string, and then I increase the index location it has. So this one is the same as the way I create a histogram, right? And then later it check whether it happened 0 times or it should happen 2 times. Only you go through the whole histogram. If there is any one not 0 or 2, then it is not double group, right? So here like this one, there's an R number, so this one's not, right? So let's create something for ourselves. When someone is happy, right? Ha 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 ha. Okay, that's wrong. It's more than 2 times, then that's not good. So this one is not okay. I saw that it's actually a. So this one is not. So here, if I cut down to this, okay, this one will be right. Okay, then if I do something else, instead of doing this, I do key A, right? I actually break it down. Not really in the continuous format. Index out of bound because I have space, so it doesn't allow space. So I have to cut this. Because there's no space. space will be index out of 1. Right? So TTAA is okay, it's a double. Every letter just happen exactly 2 times or never happen. Okay, that's what this so-called doubling word. And then it's also another histogram problem, and it is using the concept of for each loop, and also using the concept of histogram. Okay. So that's today's talk. Any questions so far?
No.
So last time we have. Did you finish your homework?
I did some of them.
You want to discuss or next time?
Next time.
Okay. Make sure next time you give me something. Okay. Last time I give you what? Exercise 3 or what?
You gave me number 1.
Oh, number 1. So this time let's add number 2 and number 3.
Okay.
Is that okay?
Mm-hmm.
That's it for today. Okay. So that's it for today. Thank you, and then good night then.
Okay, thank you. Good night.
Okay. Bye now.